Hello and welcome. I'll be explaining about the TAR project, automation of fish tank and hatchery, so water quality parameters and their amendments. The main purpose of a project is based on the problem statement that since sensors for measuring the water quality will be dipped inside water for a long period of time, which will cause some sort of degradation of the sensors and cause error in the sensors. Our main purpose is to use algorithms to predict that there is a change in the sensor measurements, or there's an anomaly, or is the sensor spoiled. What we are going to do here is collect the sensor data from the water, going to process the data using algorithms such as Z-test and SPCC, and then upload that data to the cloud. We are going to upload it along with the timestamp for better data visualization or data analytics in the future. For the cloud platform, we are going to use Firebase. Yeah. The database looks something like this. So this is the inserted data. Since we don't have any actual sensor measurements, we are going to insert dummy values inside the data. The dummy value is going to look something like this. As you can see here, the temperature value is 100, turbidity is 100, and any anomaly is false. There's no anomaly present in this data set, in this data point right now. You can look at any other data set, and it is quite similar. The temperature is 100, turbidity is 100, and the anomaly is false. You don't have any anomaly present. Now, in order to demonstrate the anomaly detection in the data set, we are going to insert data artificially. So, we are going to use this Python code to insert any data artificially. Here we can see that the turbidity value is 1000, temperature value is also 1000. And to detect anomaly, we are using two different types of algorithms. One is SPCC, which will be demonstrated for this temperature anomaly detection, and Z-test, which will be shown for turbidity anomaly detection. We are going to use these two different algorithms separately to demonstrate them. Now, let me run this code to see what happens. As you can see, one data point has just got inserted. Yeah, as you can see here, temperature is 1000, turbidity is also 1000, but the temperature anomaly is shown here as true. That means there is anomaly in this data set, a data point, and turbidity is also shown as true, which shows that Z-test as well as SPCC algorithm both have been working well to detect the anomalies. Now I'll be demonstrating you how the code works using plots. This is the code for statistical process control charts, or SPCC. The algorithm is something like as follows. It will have an upper limit and a lower limit based on the statistical data, and anything which is beyond this upper limit is called as an outlier, and we classify it as an anomaly. This is a very simple methodology, but we are here to take things a little more further by using Z-test. So this is Z-test. We'll be using alpha confidence level or alpha value as 95%, and whichever is beyond that percentile is going to be classified as an anomaly. Yeah, so this is what the plot looks like. Here, every red dot is considered as an anomaly. Yeah, as you can see, there are many anomaly data points. For every spike in data, this will be classified as an anomaly. Now, in order to little bit more take this step even more further and make this even more accurate, we will be using isolation forest algorithm to classify anomaly. So this is what the plot looks like for isolation forest. Here every red dot is an anomaly point. Yeah. So that's it for our project. Thank you.